So let's discuss about Kubernetes architecture. Alright, so before we dive into the architecture of Kubernetes, there are few terms that we need to understand. First one is, what is a node? Node is the actual hardware, the physical server where we are going to place our applications, which has the CPU, RAM and all the required resources. And the next one is cluster. Cluster is nothing but a collection of nodes. So 3 or more servers or nodes together perform a cluster. And the next one is master node. We are calling it as a control plane as of now. So this is the brain of Kubernetes. So this manages all the working and scheduling. Everything is done by the master nodes. And the next one is the worker node. So worker node is the one where the pods would be placed. It is the one which does the actual heavy lifting of placing the containers, running the containers, everything. So if you see the workloads, everything would be hosted in the worker node, and control plane consists of the components which are responsible for managing the cluster and keeping the applications alive. So first we will discuss about the worker node. What are the components that are required in the worker node? So as we know, it is the one which is going to host the applications, and it is going to be hosted in form of a container format. So what is required is container runtime. So again, the most popular one is Docker, and we also have containerd. We have other container applications as well, but I have seen mostly Docker and containerd going hand in hand with Kubernetes, and most of the people using any of these two container runtimes. And so we have this master node which is going to give our worker node instructions on what to do. So our worker node should communicate with the master node. For that, a component called kubeproxy is required. Okay, so the second one is kubeproxy, using which the master node and the worker node communicates with each other. And the next important one is kubelet. So many people say it acts as the captain. For example, when the master node senses that an application has to be placed on a worker node, what it does is it communicates via the kubeproxy and it reaches the worker node. So who receives this request in the worker node? It is the kubelet. So kubelet receives the request from the master node, and kubelet is the one who places the container in the worker node. So it decides the state of the containers, whether it has to be up, it has to be down, everything will be maintained by the kubelet. So it gives orders for the worker node on what to do. It receives order from the master node. So these three are the major components of a worker node. Now let's head over to master node. So since the master node needs to communicate with the worker node, what is required? A kubeproxy is required. So using this only, we would be able to communicate with all the other worker nodes. And the next one is container runtime again. Is container runtime absolutely required? No. It is required because if we want to place some pods on the master node itself, then a container runtime is required. And also, if you use tools like kubeadm to set up a cluster, even the control plane components get deployed as a pod. So in order for that to run as well, a container runtime is required. And now, in the first actual component of the master node or the control plane, which is the kube API server. So what we do, we have a shell terminal running and we execute commands like kubectl run pod. So when we execute this command from our machine, what it does is it communicates with the kube API server that is running on the master node. And kube API server is the one which receives the request and it does the actual orchestration of the job. So you can consider it as a front end for Kubernetes. So when we are making this request, so we are a user, we need to be authenticated, right? And the request should be valid. It has to check for the syntax, it has to check if we can schedule a pod, we have permissions to schedule a pod, everything. So all this heavy lifting is done by the kube API server. Okay, and the next one we can say is the controllers. Controllers is a pod that manages the working of the Kubernetes cluster. So we have many controllers. For example, we have a node controller. So what does it do? It is responsible for managing the nodes and keeping them active and in a ready state so that a pods can be deployed on them. So a node controller is the one who manages or controls the nodes that is present in the cluster. And there is a replication controller. What this one does, for example, I say that there should be 3 pods running at all times in my cluster, and there are 2 pods hosted here and there is 1 pod hosted here. What if 1 pod goes down? This replication controller makes sure that one more pod is either scheduled in node B or node A, depending upon the CPU resources. So it manages and it tracks that a pod is going down and a new pod needs to be placed. So all these replication activities gets done by the replication controller. Okay, and the next one we will be discussing is the scheduler. So scheduler is the one who decides where the pod would be scheduled. For example, we have node A, node B and node C. Scheduler is the one who decides a particular pod should be placed on node A, node B or node C. What scheduler does is it checks the pod and it decides the requirements, how much resource that this pod needs. For example, how much CPU, how much RAM, everything that this particular pod needs, and it goes and checks each node. If the required CPU, for example, if 2 is requested, checks if there is available space in these nodes, and depending upon that it places the pod in A, B or C. And the most important one, etcd. What does etcd do? So this is like a database where all the data is stored. It is a key value data store. For example, we can say name equal to Faisal. So this is a key and this is a value. Or we can say image is equal to nginx. So again, this is a key, this is a value. Or for example, we can say number of containers or pods equal to 3, key and a value. So every data would be stored in a key value format in the etcd database. And this is how a cluster and all the information is saved properly. So for a master node to manage all the components, it must somehow keep a track of all the data. When a pod was created, when a node was added to the cluster, all this needs to be saved somewhere, right? So etcd is the place where every data is saved. And why we use etcd? Because it's simple, secure and fast. That is why we use etcd. If you have any further questions or suggestions for future videos, please leave them in the comments below. We value your feedback and look forward to hearing from you.